Hello and welcome to Math200 Statistics here at Kenyatta College. My name is Ray Lapuz. In this video, we will wrap up Chapter 1 from our textbook and go over Section 1.4, where we're going to take a look at some experimental designs and a little bit of ethics. So what's the idea behind an experiment? We can ask questions. We can call these research questions. Things like, does an aspirin reduce the risk of heart attacks? Or is one brand of fertilizer more effective than another? So there's many types of questions that we can ask, and these questions can be answered by, well, at least statistically, they can be answered by doing an experiment where we would collect some random sample and then do the experiment on them. And then after we do the experiment, we can collect the data out of that experiment and then decide whether something is significantly different enough, or if we're trying to prove or disprove whatever it is we're trying to look at. So in terms of an experiment, there are a few vocabulary words that will probably be important for us. We all know about the populations versus samples and the parameters versus statistics that we would collect. So a few more important terms that we might need would be the explanatory variable. So a variable that causes the change one change from one variable to another. The first variable is called the explanatory variable. And then as the explanatory variable changes, the second would be the response variable. So the explanatory and response variable will become important for us later on as we study associations between two variables. And we'll see that in correlation and regression. We all can also take a look at a randomized experiment, and then the researcher can change the values of the explanatory variable and then observe to see how the response variable changes. So the different variables or different values that go into the explanatory variable would be called treatments. And then finally, an experimental unit is a single object or individual that we're measuring. All right, let's take a look at an actual example of a research study, an experiment, to see if we can identify some of these things. So here in our example, we have a researcher who wants to investigate whether taking aspirin reduces risk of heart attack. So 400 men between ages 50 to 84 are recruited as participants. The men are divided randomly into two groups. One will be taking the aspirin, and then the other will be taking a placebo, which is a pretend aspirin or a pill, where it's really just a fake pill that has nothing in it. And so each man will take a pill and for 3 days, and then at the end of the study, researchers will count the number of men in the group who've had heart attacks. So for this particular study, let's try to identify the following. Let's try to identify the population, the sample, the experimental units, explanatory and response variables, and the treatments. So let's first tackle the first two, the population and the sample. So we're looking at 400 men in our study, so that's going to be the sample. And these men are between 50 to 84 years old. So the population would be all men who are ages between 50 and 84. And then the sample would be those particular 400 people. The experimental unit would be each person or each man in the particular study. Okay, explanatory variable. Explanatory variable will be the aspirin or the placebo that they're going to take. So this is going to be we can look at it as a qualitative variable. Did they take the aspirin or did they take the placebo? And so that is going to be the explanatory variable. The response variable will be whether the man gets a heart attack or not. And then so the treatments are going to be the types of pills that they take. All right. So in summary, the population will be all the men. The sample would be the 400 men in particular. Each unit would be each individual person in the study. Explanatory variable is the oral medication. The treatments are going to be either the aspirin or placebo, depending on what they took. And then the response variable is what happens at the end of the study. Did the person have a heart attack or no? All right, so that's the rundown in terms of experiments. Now let's take a look at some ideas behind ethics. So here the U.S. Department of Health and Human Services oversees the federal regulations for research studies, the aim of protecting the participants. So when a particular entity, a university or other research institutions engages in research, they must ensure the safety of all human subjects. So this is very important. We're looking at the CDC going out and trying to find subjects for their study to test vaccines to see if they work. And so in looking for the subjects that they're going to collect, it's important that they abide by some rules. So for this reason, the research institutions established an oversight committee known as the Institutional Review Board, and all planned studies must be approved in advance by the Institutional Review Board to make sure that they are protected by law in doing the study. So they must know, the people who are in this, they usually sign forms to make sure that they know that they're going through a particular study, and they must know, or they must be informed about the risks that so the risk of participants must be minimized, reasonable in respect to projected benefits. Participants must be given a consent form, so the risks are explained clearly so that the subjects that are in the study know what they're getting into. And data collected from the individuals must be guarded carefully to protect their privacy. And so that part, whenever, like I said, the perfect example in this day and time would be the CDC going out and doing studies on their vaccines. And so before they actually go out and do their studies, they have to make sure that they abide by these laws, these principles, so that the participants know exactly what they're getting into, know the benefits, the risks, and the benefits of what they're getting into in their experiment. And they also are protected so that their information is not going to all of a sudden be available to the general public. Okay, so that's it. That closes our first chapter in our Introduction to Statistics. Now that we got a lot of this out of the way, a lot of the vocabulary and terminology, we're going to dive into a lot of the computations in statistics, and we'll move from there. All right, good luck.